Okay, so in this case we've got to show that dy dx is t minus 4 over 2t. So we'll differentiate this here. So dx by dt is equal to 4t, yeah? You bring that 2 down, minus 5 disappears. Okay, becomes 0 and you differentiate it. Here then dy by dt is equal to 2t minus 8. Okay, and of course then flip this to get dt by dx. Okay, so you get 1 over 4t. So then using the chain rule, dy by dx is equal to, well, dy on top, dx on bottom. So 2t minus 8 times 1 over 4t. Okay, so this becomes 2t minus 8 divided by 4t. And if you notice then there's a factor of 2 in top and factor of 2 in bottom, so I could divide top by 2, and as long as I do the same to the bottom then, there's nothing wrong with that. So divide the top by 2, that'll become t minus 4, and divide the bottom by 2, 4t divided by 2 is 2t, and I've got exactly what they want. Now, to find any stationary values in the curve, now if you remember, stationary values is where, okay, the curve could have, for instance, a maximum or a minimum. Okay, that's one, those are two possibilities, yeah? So if you remember, okay, at the stationary point, the gradient is 0, yeah? It doesn't have to be maximum, it could be point of inflection as well, but just to illustrate the point here that the gradient will always be 0. So we say that at stationary points, dy dx will equal to 0. Okay, so we've got dy dx here, t minus 4 over 2t will equal 0. And if that's the case, that means the top has got to equal 0. Okay, for the whole thing to equal 0. If you want, you can think of taking that 2t over the other side and multiplying. So when you divide in by 2t, take it over and multiply, and 0 times 2t is just 0. So it disappears. So therefore, t minus 4 is 0. So t is equal to 4. Okay, so the stationary point occurs when t is equal to 4. And we can actually find the coordinates, can't we? So when t is equal to 4, x will equal to 2 times, so again, going back to these now, right, from the start, just sub t in, 2 times 4 squared minus 5. So if I do that, I get 27. And y will equal to 4 squared minus 8 times 4 plus 3. Okay, so I get minus 13, I think, there. So stationary point, I can say, occurs at 27 minus 13.